Okay, we're looking at density, and the starter question is which is heavier, iron or wood? Thinking about this carefully, the word heavier, what does it mean? Well, it's really asking us about mass. Mass in kilograms. And of course, the answer to this question depends on the amount of volume of each of these two objects, iron or wood. So the better question would involve a question about a given volume of these two objects, and then the answer would have to involve both mass and volume. So one concept that does involve this, of course, is density. Symbol is rho, where density is mass per unit volume. So the better question really is which is denser, or which has the greater density, iron or wood. The formula for density, we've just seen that, is mass divided by volume. And the units. The units, well, there are two types of units. We can use kilograms for mass and divide by cubic meters for volume. So we'd write per cubic meter with a minus sign there. And the other option is to measure the mass in grams and the volume in cubic centimeters. So it'd be grams per cubic centimeters. So these are the alternative units for density. To go from one to the other, you need to multiply or divide by 1,000. To go from grams per cubic centimeters to kilograms per cubic meter, you have to multiply by 1,000. Here's an example. A brick has a volume of 2,000 centimeters cubed and a mass of 6 kilograms. Calculate its density. You may notice that we have cubic centimeters and kilograms. Now we can't make a standard unit for density with these two. We need to change one of these quantities into other units. I think the easiest thing to do here would be to change the 6 kilograms into 6,000 grams. So we'd write density equals mass over volume. In this case, our mass would be 6,000 grams, and that's divided by 2,000 cubic centimeters. So we get 3 grams per cubic centimeter as our answer for density. And question number 2, an engineer needs to know the mass of a steel girder which is 20 meters long, and you have a cross section of 0.1 by 0.1. So to find the mass, given the density of 8,000 kilograms per cubic meter, we need to rearrange the equation and find mass equal to the density multiplied by the volume. Now, you should be able to work this out yourselves, and if you get an answer of 1,600 kilograms, you are indeed correct. Example number 3, an object has a mass of 3,000 kilograms and a volume of 25 cubic meters. What is the density? Density rho equals m for the mass over v for the volume. So we'd simply put these numbers in because the units are nice straight away. So 3,000 over 25. And that should give you 120 kilograms per cubic meter. Number 4, an object has a mass of 120 grams and a volume of 38 cubic centimeters. What is the density in grams per cubic centimeter? Once again, dividing mass by volume. Here would give us 120 divided by 38. And that should be 3.0 2 or 3.16 to 3 figures, grams per cubic centimetres. And what is the density in kilograms per cubic metre? You simply need to remember the rule multiplied by 1000 to get the number in the correct bigger units of kilograms per cubic metre. So we have 3,160 kilograms per cubic metre. Now we need to know how to measure the density of liquids and solids. Starting with a liquid, the way to do this is to take an empty measuring cylinder and determine its mass, and we'll call that M1. We can use an electronic scale to measure that mass. We then add a certain amount of liquid to that measuring cylinder, and we can easily measure the volume of liquid added just by looking at the scale. And we put this back onto the electronic scale and measure the mass again. We have mass 2. Then of course, to get the mass of the liquid only, we'd have to subtract these two masses, M2 take away M1, and the density can then be found. We can read off the volume, of course, just from looking at the scale there. As we've seen before, simply mass over volume. But this mass of the liquid, call it ml, that of course is found from the subtraction of M2 and M1. To measure the density of a regularly shaped solid, it's quite easy. You just measure the length, the height, the width of the solid and multiply those three dimensions together to find the volume, to calculate the volume V. Of course, if it's a sphere or something, it's a bit trickier, but thinking about a cube, this is quite easy to do. Measure the mass M of the solid using scales, using electronic scales perhaps, and once again simply dividing mass by volume therefore will give us the density. Now for an irregularly shaped solid, something that's not particularly easy to measure with standard rulers or measuring tapes, something irregular like perhaps an old capacitor or some stone or something like that. The way to do this is to use the displacement method and place it into a known volume of water in a measuring cylinder. So placing the object inside there as an irregular shaped object, pop it in, of course the water level will rise a certain amount. That change of volume must be equal to the volume of the irregularly shaped solid. So we can subtract the two volumes on the measuring cylinder, V2, take away V1 to find the delta V, and that of course can then be used in the formula. We can measure the mass of the irregularly shaped solid just as before using electronic scales. So once again we use this equation to find the density.